Hello, my name is Professor Allen Hoffman. I'm in the Mechanical Engineering Department at Worcester Polytechnic Institute in Worcester, Massachusetts. The subject of this video is going to be material selection for building prototypes. Now, the first thing we need to do before we start talking about material selection for prototypes is to define what kind of prototype we're actually going to build, what its purpose is, and how we are going to test it after we've built it, or test it or evaluate it. So a prototype is a physical representation of a product that is used to resolve one or more issues during product development, one or more design issues during product development. Why should we build a prototype? Essentially, why should you be building a prototype? Well, there are several reasons that one might build a prototype. I'll elucidate on 4 of them. Learning. Essentially, what is the customer appeal? Judge customer appeal of our potential product. Certainly, will it work? That's a good reason to build a prototype. Pure communication with customers, management, vendors, or in our academic environment, faculty. Integration of subsystems in a more complex system. And milestones, to demonstrate that we've met certain milestones in product development. In essence, a prototype has to demonstrate some level of feasibility. Okay, so finally, we're down to selecting materials for your prototype. Sort of essentially the title of this videotape, Material Selection Factors. The materials you select for your prototype must demonstrate functionality. If you're testing load-bearing, if you're prototyping a load-bearing device, the final material or a similar type material should be used in the prototype. If load-bearing is not as important, still there, but not as an important design criteria, since you might be able to meet it with lesser quality materials, you could then, indeed, your prototype could use the lesser quality materials. So here are the basic material selection factors. And again, since I've been in university, a little bit of this discussion is based towards student design, student development of prototypes. Number 1, availability of the material itself. The quantity you need, the delivery time, where you can purchase it, perhaps online, or better still, at the local Home Depot or the local Lowe's. Availability plays a big role if your prototype development time is short. And I've often seen good designs not being able to be fully prototyped because the parts were on back order. Cost. Cost is always a factor in building a prototype. We want to make it as low cost as possible while still meeting the minimum requirements of the prototype, be it 0th order, 1st order, or higher order. Manufacturing time is a big consideration in material selection. If at all possible, you want to be in full control of the time to manufacture your prototype, and therefore be able to meet your stated deadlines in the product development process. If manufacturing is highly sophisticated, it likely involves others, and they may not be working on the same timeline that you need to fully develop your prototype and have time to test it, have time for clients to evaluate it. Ease of assembly, or is not necessarily quite independent of manufacturing time, but can you form the component parts, form or purchase the component parts within the facilities you have or within the resources you have. Now we get to material properties of, or properties of the materials that you would select. Certainly you need adequate strength to evaluate your prototype under real life conditions. Again, thinking of a zeroth order prototype. Weight will impact usability or the opinion of usability based upon your customer base that you would probably show this prototype to. It's a difficult road to hoe that if you show somebody a functional design, you say, okay, we're going to redesign it and make it 50% lighter. Well, your consumers or the people who are evaluating your usability won't be able to judge that very well. Certainly you need to have material strength for the appropriate loads, and the material has to withstand the stresses for the appropriate evaluation. Weight, again, I sort of alluded to that. Weight will impact the bulk of the material and also the amount of, well, it will impact the usability of the device. Certainly we have to think about how formable your material is, its ductility, its ease of machining or just basic operating, drilling holes, threading the holes, things like that. So essentially brittle materials are probably undesirable unless that's what your final product is, unless that's a thing you want to test in and of itself. Durability usually is of lesser importance in first order prototypes and maybe even second order prototypes, because you can project durability by proper and final material selection. We obviously want the material, the prototype, to be durable enough to fully withstand the test procedures the prototype was intended to undergo. Now, the last item on the list is aesthetics. Aesthetics may or may not be that important in a first order prototype. In the field in which my lab works in, that is development of assistive technology, we're going to show it to clients who have disabilities. Aesthetics might play a big role, particularly if we have a wheelchair attachment. Wheelchair attachments for someone who is confined to a wheelchair, that's part of their persona. I always ask my students who are designing in the area of assistive technology, assuming that you had more than one choice of what you wore as clothing today, would you select the thing that least appealed to you? Now what you're seeing on the screen at this point is a very basic chart of materials, some of their availability, some of their applicability, some of their advantages, and some of their disadvantages. And what we have on this chart is wood, metals, plastics and polymers, and ceramics. Now wood, its advantages are it's readily available, it generally is easy to work with, oftentimes you yourself can control the manufacturing time. It has adequate durability, stiffness, strength. The strength to weight ratio is good, its weight may be a little bit on the high side. So readily available, easily formed, easily assembled, durable, certainly at the prototype level. Disadvantages, if you're talking about something that operates through numerous cycles, its wear properties are not as good as metal, and it has less load-bearing capabilities. Metals again are readily available. They're very strong, they're ductile, they're durable, they're more difficult to assemble than wood. Manufacturing time depends on what the manufacturing processes have to be and whether you're capable of doing them. Strength and stiffness are good. Strength to weight ratio is good. Plastics and polymers, reasonably available, more formable than metals. May have temperature sensitive properties, so if you're drilling and using machining processes, you're going to have trouble maybe maintaining high dimensional tolerances, and hence they might be time consuming to manufacture. Over on the far right of the table, ceramics, they have special properties. I would suggest only such as chemical resistance, coating, dielectric properties, and things like that. I would suggest not using those for first order prototypes unless that's a critical requirement of your prototype. So, in conclusion, prototype construction should not, and materials available for prototype construction should not be an afterthought that you approach after you have designed or figured out what your first order prototype is going to look like. That's really too late in the process. Prototype material selection for prototypes should be identified and thought about and strongly considered before you actually design your prototype, to make sure that you have access to the materials, that they are the right materials to demonstrate the level of feasibility of your design that is required by the prototype that you have decided to build. So material selection is important, although it often occurs in many engineering processes towards the end of the design process. I'm advising you to consider it very early on, and it should not be taken lightly, because unless you have made the right or at least a correct, not necessarily the most optimal, but a correct selection of material properties, your prototype might not exhibit the functionality or the durability or the strength or to meet the goals of the prototype. This concludes the video, and I'd like to thank you for viewing.